want both of them now? Okay, where were we? Yes, so one of the interesting and defining trends for how web applications are changing is the increasing amount of asynchronous request handling, currently moving also to non-blocking, which is a whole another big subject area. But originally, the Servlet API and Servlet containers, I think the first version of Servlet API was back to 1997 or so, basically late 90s. Obviously, those were very different times for developing web applications. They were, you know, Ajax wasn't invented. The whole REST versus SOAP was yet to happen. A lot of things, it was ahead of all of that. So basically, it was designed with synchronous and blocking semantics, where you have a chain of filters leading up to the invocation of a servlet, and you have a single call stack assumption, kind of a single pass through the entire processing, which makes it easy to write your logic. It makes it easy to think about it, but it also means that introducing synchronous and non-blocking behavior is quite difficult and challenging. Later on, around version Servlet 3.0 introduced asynchronous behavior into the Servlet API. It's something which in practice we found that is quite easy and quite possible to do. So for example, if you take any existing Spring MVC controller method, whatever type that may be returning, you can turn that into an asynchronous method by simply replacing the return value t with deferred result of t. And what this allows you to do is it allows you to do exactly the same as before, except to do it from another thread at a later time. So that means, for example, that you could make a database call which may take a while, or you may make a couple of calls to HTTP services that may take a while. You may do scatter gather techniques, anything which is latency sensitive. And when you're ready from any additional thread, you can call deferred result set. Basically, what happens in the meantime is that you return from the handle method, returning essentially a promise for the return value. Then we exit all the way out of the filter chain back to the servlet container. So now there's no more servlet container thread in use. Now we can set the result later on and then complete processing from there, just like we would before. So essentially, you're making the entire handling, separating the completion of the response rendering from the handling of the request, making the whole thing asynchronous. A use case for that might be not only things like that are latency sensitive in the sense of how long it takes to process, but it's also for the kinds of requirements where a web application needs to display some sort of a live event based on kind of a again, latency sensitive situation. So for example, if you're modeling a chat application and you're talking to a server representative, to a client service representative, if they type something in, you want that information to be shown as soon as it's been typed. So what you want with HTTP is the long polling technique where you make a request to the server, and when there is information, we want to then stream it back send it back on the response. And because HTTP is a request-response paradigm, you can't really initiate anything from the server. You have to start it from the client side and then wait until there's a response, which means that there's a significant delay, maybe 30 seconds, maybe a minute. Usually that's about the boundary where you want to keep the long polling. because of various kinds of proxy issues, proxies that may kill the connection because they think that it's been going on for too long. But basically, that's the long polling technique. And as you can see in the programming model, it's really easy to actually do in Spring MVC. And behind the scenes, there's actually quite a bit going on, and it's not so straightforward overall, again, because it's being introduced on top of a originally synchronous and blocking programming model. But as this proves, it's actually possible to do, and it's not very difficult to introduce into existing applications. Anyone using this feature? Okay, a couple of hands. Right, so basically the thing to keep in mind is you can take any existing controller methods and you simply replace the return value with deferred result, and that allows you to then complete, just like you would complete a future, with some sort of a concrete result that we can continue processing with after that. Or you can also complete with an exception. So if the handling failed for some reason, you couldn't make the database call or something like that, then you can set it to an exception, and then that would proceed to handle as if the controller method had raised an exception, and that will go through the exception resolver mechanism and so on. Of course, the one catch about the deferred result is that you only set one async result. So you get only one option to set it to something, which is good for long polling. So as soon as you get the result, let's say this is a chat style application, you make a call to the server and you wait until there's a message. And if within the time of the long poll duration, maybe 1 minute, there is a message, you send that back to the client. Then the client makes another long polling request, and you keep doing that, to maintain the chat. In fact, if you're in a browser ever chatting, you may be curious, look in the network panel, network tools, and you can see that that's exactly what's going on, kind of a continuous polling, usually within a one minute or 30-second boundary. And if there's no result within that minute, then you basically have to return empty, and then the client continues to do that, and that's basically how you maintain that communication. Now, the next thing is, how do you do HTTP streaming, where a little bit more efficiently you maintain an open connection, and you send not one thing, but you continuously send many things back to the client. So this is a more recent feature that goes back to Spring MVC, Spring Framework 4.2. This is where you can return a response body emitter. So this is more closely aligned to the response body style methods or response entity controller style methods, where you use some sort of a message converter to do JSON, to write JSON back to the client, for example, or maybe a string, or maybe XML. So with the response body emitter, it's very similar to a response body, except you can give it many objects over time and from any thread with some duration in between. So basically, you're streaming data to the client over time. And of course, there's also a SSE emitter subclass, which is for server-sent events. Server-sent events is essentially HTTP streaming with a particular kind of markup around it, which is understood by browsers. It's basically a W3C standard for how servers can stream data to clients and put some data around it to signify what is an event, if there are more events coming, and so on. What is the event ID? And then browsers know how to take that event and process it on the client side. So this is an example of using the emitter. So first you return an emitter, and then from some other thread later, you can send some data to the client. Then some time later, you do the same, send some more data. And then when you're done emitting, then you can basically say complete. At this point, the connection is closed. Now, I mentioned proxy issues earlier, that sometimes proxies can say, well, this connection is going on for too long. So here you're still exposed to that. So that's why in the real world, you won't find necessarily too many examples of this, but depending on your situation, you may have a network configuration, maybe it's an internal application where streaming may be appropriate and it may work. But in general, over the internet, it may be difficult to do this simply because you won't be able to stream for that long without some proxy interfering in the middle. And for that, you will see also some better techniques later on with WebSockets. For server-sent events, conceptually very much the same thing, except what we're doing here is we're using an SSE emitter builder, which allows us to specify an ID for the event, the data for the event, that's the object that's being serialized. And there's other things as well, but otherwise it's very, very similar. And so we talked about asynchronous handling, we talked about streaming, and that allows you to break the relationship between a thread per request, right? Traditionally and originally in a servlet container, you have one request per thread, and with long polling or HTTP streaming techniques, you can see how it's completely not sustainable. I mean, if you start holding up a thread for every request and it takes 30 minutes, 30 seconds to 1 minute, you're going to quickly exhaust the thread pool. So with streaming and async request handling, that gives you an opportunity to avoid that. However, you're still in a situation where you have blocking I/O. And to understand really what that means, consider what happens when we actually say send and we give some data. If you have a slow client on the other side, maybe it's a mobile, over flaky Wi-Fi, and it's not reading, the network is not flowing very fast. That means that when we ask the server to write to the response, that response may take a while to write. So now we're holding up a servlet container thread. That's what we mean by blocking I/O. Essentially, that's the original servlet API where we take the output stream, and it's like a regular Java output stream, and we say output stream.write, and until the write is done, we're holding up a thread. So that's what we mean. With async request handling, we can separate the servlet container thread from the handling of the request. But when we actually start writing the data to the response, we're still using blocking I/O. And as it turns out, well, first of all, I should mention that in Servlet 3.1, there is a non-blocking API, non-blocking I/O API. Anybody has seen that or looked at it? Okay, no hands. And that's not surprising because it's, I would say it's a bit of an island on its own. It's off of the servlet input and output stream, and you can register a read listener and write listener. And what that allows you to do, going back to that scenario with the slow client, let's say you have a slow client and you don't want to hold up the thread. So now what you're supposed to say when you switch to non-blocking mode, you're supposed to say, are you able to write? And the servlet container can tell you back yes or no. And if the servlet container says no, that means that you have a registered listener, and then they will call you back when you can actually write. So if you think about what that means really about writing applications, that's a fundamentally different way on a very low level of writing applications. To make your servlet application truly non-blocking is a very, very deep change. It means that you can no longer simply write to the response stream. You have to be prepared to do that multiple times when the server is ready calling you back. That really breaks the flow of the logic. The way you write your logic asynchronously is completely different. And that's something I'm going to be talking about in a lot more detail tomorrow. So effectively, this is why we don't think we've tried to take the Servlet 3.1 non-blocking I/O, and we've tried to integrate it into Spring MVC and make it available just like we did with Servlet 3 async requests. And what we found is that this is virtually impossible to introduce into an existing set of applications and ecosystem of frameworks. And so what we've done is we've embarked on sort of a journey of building an asynchronous non-blocking alternative to all the functionality which is currently there for Spring MVC. Effectively provide the same Spring MVC programming model on an async non-blocking foundation, a kind of a new reactive web engine. There's going to be a lot of shared stuff, like the annotations and the whole program, the way the programming model works, request mapping annotations and everything. But underneath, we have to change a lot of the contracts to make them completely asynchronous and non-blocking to be able to deal with this kind of way of writing to clients. And it's not necessarily something that applications have to switch immediately, but it's definitely an important area that we see where things are going, and we're investing very heavily in that area. This is an example of a non-blocking controller. And again, this is version 5. This is future work. This is something that we're working on today. You may actually be underwhelmed that this looks a lot like an existing Spring MVC controller, and that's the idea. The idea is that the programming model doesn't change very much, but what's going on underneath is a sea change, is quite a big deal. So for example, you can see here that there's a request body declared as a method argument, and that's a type called observable, which some of you may recognize. It's RxJava type. How many have seen or played with RxJava? Okay, a few hands. So basically, RxJava is one of a number of emerging frameworks that allow you to do reactive programming, kind of declarative style async logic composition. So where in imperative logic, you can write your code from top to bottom, and you can say, this happens first, this happens next, then I'm writing to the response output stream, then I'm doing this. But that's blocking, right? Because each step has to complete before you take the next one. In async applications, it's a lot, if you think about what you do with a feature, a Java feature, you wait until the feature is done, and then you do something else. So that's, RxJava is in that space. It allows you to declare steps of logic and broken out. Those are asynchronous steps, which will happen one after another. And again, I'm talking more about that tomorrow, but basically here you're taking the request body non-blocking style. This controller method will not be invoked until the body has been fully read, and then you can start to use that yourself. And again, in the programming model, it doesn't look like much, but under the covers, this enables a new level of scale. Because when you're non-blocking, it means that you're not holding a thread from the server. If there's a really slow client, that's not going to drain your server thread pool, because you're not holding a thread while waiting for a client. In fact, you're always being notified when you can actually read, so you're maximizing the use of resources, a much more efficient way of using resources. Anyone played around with Node.js? Okay, so if you've played around with Node.js or looked at it, I think you will be familiar with the concepts. I mean, you know, Node.js came as JavaScript, and as you know, JavaScript was traditionally client-side and single-threaded platform. So when they came to the server side, it was pretty much a constraint from the beginning that they had to make the most out of a single thread. And it's interesting that it's something like Node.js, a single-threaded environment, that platform, that demonstrated kind of, if you've heard of this 100K connection thing, where they demonstrate that with a single server, you can support 100,000 connections. And it's interesting that a single-threaded platform was one of the first to kind of push things, set the bar, and demonstrate what you can do with very efficient use of resources. Of course, in their case, they really had to. And we're talking about replicating that experience in Java, which is a major undertaking because it means changing an entire ecosystem of libraries, not just one here or there. And that's what we're doing on our side in Spring MVC. And of course, it has some implications for the way you program, but there are quite a few benefits to it. And here there's a non-blocking repository as well. So it's an entire stack of non-blocking components. Again, that's my second talk tomorrow at 4 p.m. where we're going to dive into this aspect of things a lot more. Anybody playing with reactive or doing anything of that nature? Okay, a few hands. definitely a space to look out for. So very much related to the asynchronous processing is WebSocket architecture. But I've kept this as a separate section because it's really mentally a very different approach to messaging. So with WebSockets, you have a messaging architecture. This is very different from REST and HTTP. So in REST and HTTP, you have requests coming in. They can be cached. Each request has an HTTP method. There's a URL. And you can use that information to kind of create controllers and map requests to specific controller methods. In messaging, you start the connection, and then you have messages flowing in both directions. That's a radically different way of building applications and thinking about applications. But it's much better suited if you have a situation where you want to do web messaging. If you want to, maybe chat is not the best example because chat is actually relatively easy to achieve. But if you have a more advanced messaging architecture, like for example, think about a collaboration application, where you're doing stuff online together with others. Think about gaming, online gaming. Anything that's on that level of interactivity, you can imagine that simulating that with long polling and HTTP streaming becomes very limiting because you have all kinds of messages coming in and you want to be able to kind of delegate these messages to the right place, handle different kinds of command messages. Then you also want to have broadcasting abilities to target specific subscribers. It's a completely different way of thinking, but if you need that sort of thing, that's really the right direction. And what we've done in the Spring version 4 is to make that relatively easy to get into, kind of very familiar to Spring MVC developers. Traditionally, messaging is more, if you've done JMS or RabbitMQ, you probably are familiar with, that sort of architecture. So, but if you're coming from a web development background, that's not something that comes easy or natural. So WebSocket, first of all, is a very low-level protocol. Imagine working with TCP without HTTP on top. That's pretty much what WebSockets is. It's kind of a very thin layer on top of TCP that gives you nothing but blank messages. Kind of cuts the TCP stream into messages of certain size. But then what's in these messages is entirely up to you. So again, imagine HTTP without the methods, without the URLs. Like, what do you do with the incoming data? So WebSocket actually has a sub-protocol mechanism which allows you to use a proper application level messaging protocol on top. And we've picked STOMP, which is quite suited for this. It allows you to have a message broker. So now you can actually take subscriptions from clients, and then you can broadcast to relevant subscribers. So it gives you that kind of functionality. So here's an example of, for example, some browsers using StompJS, for example, on the client side. And then on the server, you have a Spring application running in Tomcat, Jetty, or any servlet 3.1 container. WebSphere, Liberty Profile, and also WebLogic now support WebSockets. So basically, initially, we have a WebSocket handler which deals with STOMP messages. You can see that the first box on the left. So when the message comes in, that's not simply a WebSocket message, but that's formatted in terms of STOMP frames. And those are very simple. They're a lot like HTTP. They're very inspired by HTTP content. You can see there's a subscribe command. And then there's a destination. And that destination tells us what the client is interested in. And this message goes into the message broker, which is, in this case, in-memory message broker. It's there. It's provided to you. And it takes that subscription. And now the next thing that the client can do, the client can send messages to the server. In this case, that's the send frame. Message frame. In this case, this represents a command. So the client, in this case, is executing a trade. It's sending a message that says, I want that trade executed. And this is why having kind of a Spring and WebSocket application layer makes sense there, because it's just like in HTTP, you're processing a request over post, In this case, you're taking a WebSocket message and you want to handle and process that trade. But the difference with HTTP is where with HTTP you're sending a response back. In WebSockets, there's no notion of sending a response back. It's messages are coming in one way. You can send messages the other way, but there's no concept of request reply. You have to somehow indicate who this message is for, and that's why we have a message broker, etc. So, for example, let's say when the trade is done, we're using annotated controllers, and it looks something like this. This is an example of a controller. And just like a regular Spring MVC controller, you can have request mapping methods in here. But here you also can have message mapping methods, and those are dealing with incoming STOMP over WebSocket messages. So you can see that the model is very, very familiar. So now when the controller wants to send a message to relevant subscribers, it sends the message to the message broker using a messaging template. I think I have an example of that, like here. You can see there's a messaging template which is injected into the controller. And in this case, I'm actually doing it through an HTTP post, just to show that you can broadcast to connected clients from anywhere, including an HTTP request handling method. So in some cases, you may actually accept incoming data over HTTP post. It may be convenient to broadcast in that way. Then you turn around and you give that message to the broker, and the broker figures out what are the connected WebSocket clients that are actually subscribed to this topic, and boom, you're targeting those connected clients. So you can see that lifts web messaging to another level. It's no longer long polling and HTTP streaming. You're not dealing with individual HTTP requests. You're just dealing with messages. So what's the client library look like? So there's a StompJS client. It's very straightforward. It's basically you give it a WebSocket, and after that you're connected, and you say it's a very simple API. STOMP is a very simple protocol. It's just basically about subscriptions and sending and receiving messages. There's a callback mechanism. So. Yep.
Would this be a plugin on the browser, or will it do polling internally?
So the question is this a plugin in the browser, or is it doing polling? That's a good question, actually, which is leading into my next topic. So it's a WebSocket connection. So browsers starting at certain versions, mostly I'm talking IE, starting at version 10, they support natively WebSocket. That's an HTTP spec which is supported in browsers, starting at specific versions. But if you're talking Chrome or Firefox, they've been supporting it for a while now. But in some cases, the browser may not, like IE 8 or 9, they will not support WebSocket natively. Or you may have very restrictive proxies that will not allow these connections, either because they don't understand it, or they're not configured to allow long-running connections. So what happens in that case is that you need to fall back on long polling, on HTTP streaming. But what's really nice about SockJS, and Spring implements the SockJS protocol, which basically allows you to emulate a WebSocket connection, meaning a two-directional connection between a browser and a server, using HTTP polling and streaming techniques. And there's a relatively sophisticated algorithm for falling back, depending on the browser and depending on the behavior when you try to make the call, if it succeeds or fails. It has a kind of a fallback mechanism to try and pick the protocol. So you may start out with WebSocket, and if it's not able to do that, or maybe it's not running in the right browser, in which case it won't even try, then it might go to streaming depending on what browser you're in. But if you're in IE, certain versions 7 and 8, you can do cross-domain AJAX, but that doesn't allow you to do cookies. So then it will go to a separate technique where it opens an iframe, then it maintains streaming from there, or it may fall back to long polling. So there's quite a bit of sophistication there to pick based on the right browser and emulate WebSocket connections. But what's cool about that is that you're ultimately just enabling an option on the server side that says use SockJS. And then from there, it just works like WebSocket API, and it adapts, it falls back to long polling if necessary, but you're no longer dealing with the mechanics of long polling in the browser. Question?
That would be a plugin for the browser.
So on the browser side, you're using either WebSocket, or if you're using SockJS, there's a library called SockJS Client.
Like I say, I have to support 8 and 9 and 10.
Yep.
Then I wouldn't want to do pure WebSockets because it doesn't work prior to testing.
Yep.
Something like this. Service would indicate correct?
Yep. And I should have included an example of this, so I'm just going to show you an example of what it looks like on the client side. So on the client side, this is an example, a stock portfolio example application. Let me see. Might be a little small. Is that all right in the back? Yep. So here you can see that first of all we're creating a SockJS, and that's using the SockJS library. Up here you can see all the libraries. I mean, besides jQuery and Bootstrap and Knockout, which are just the UI, this is the SockJS and STOMP libraries. And typically you might do new WebSocket in a browser, but in this case you're using new SockJS, which gives you kind of an emulation of a WebSocket. And then you're passing that to STOMP, and you could as well pass WebSocket here. So it's a minor change on the client side, and now you're using a library which will do the right thing and fall back. On the server side, your configuration looks like this. This part with, so I can remove this part of the, by the way, this shows you also on the server side how easy it is to achieve this. This is the configuration that you need to start. Basically, you're indicating where is your WebSocket SockJS endpoint exposed on the /portfolio. That's where the handshake will occur. And also you're choosing whether to enable the simple broker, which is an in-memory broker that we have that automatically keeps track of subscribers and knows which sessions have which subscriptions. Or you can enable what's called the STOMP broker relay, and that allows you to use an external STOMP broker like ActiveMQ or RabbitMQ. If you already have that, you just add the STOMP plugin to that, and then it basically just uses that as the broker. So it's really easy to get started. And then if you need SockJS on the server side, you simply say with SockJS, and now the rest of your code works just the same. So for example, there is a portfolio. This is an example controller. And you can see that we have a mapping for a trade message. So this is where we execute a trade through a trade service. And if you look in the trade service, well, it's simulating the execution of a trade, but the point is that at some point it's calling the messaging template and it's sending a message to that user. It's not a request-reply paradigm. You have to actually initiate a message from the server side. It's a true messaging architecture in two directions, but we try to make it look very familiar and feel like what you might be used to, kind of a strike a balance, you know. Between Socket.io, kind of easy, and something more sophisticated that gives you a little bit of structure, like the STOMP protocol. So the client, does it open a connection from the server side? There's a running connection. So with WebSocket, the browser sends initially an HTTP request, and that's a handshake. The connection gets upgraded, and that socket remains open, and it's used for bidirectional communication. Now, if you have to fall back to long polling, what happens then is that the browser keeps using a long polling connection, which gets recycled every minute or so. That's for the receiving from the server side. For the sending to the upstream, it uses a second connection to make HTTP posts, so it simulates two directional using HTTP when it needs to fall back. Yeah, so if the proxy interferes, it will fall back to long polling, and it will work. Yeah. In fact, I recall in the early days of testing when we used a Java EE server that didn't support WebSockets yet. It would just work, and I would get excited. Wow, this works, and it's actually doing long polling because it falls back to the long polling technique. So that's what's cool about that. Sure. Feel free to ask me more questions. So the next section, we're going to talk about changes in the programming model. One of the noteworthy items, things that we've done is built-in support for cross-origin resource sharing, which is obviously an important topic for many applications to ensure that if your application should not be accessed from different domains, let's say you're visiting evil.com and you're at the same time logged into Amazon, evil.com shouldn't be able to make calls to Amazon with your logged in authentication using your cookie information. So that's where CORS becomes important. And of course, there's always been other solutions in place, like you can find filters from Tomcat, from Jetty for doing CORS, and that's what has been done for a long time. So it wasn't ever like a super urgent item, but we decided to add it because in Spring MVC, we already know a lot about the request mappings, and we are in a good position to support CORS on a very fine-grained level. So we have both global and fine-grained config. That's really where the feature came from. And you can layer them together. So for example, you can go down on the level of a controller and you can put a cross-origin annotation. Or you can go down on the level of a controller method even and put a cross-origin annotation. And at that point, we can do a lot of things with that. We already know which HTTP methods this controller method allows, and we can automatically expose that kind of information for pre-flight requests. And it also means that now when there's a pre-flight request, the handler mappings actually understand pre-flight requests. So a pre-flight request is where the browser is actually proactively asking, is this client from this domain allowed to access this particular resource before it actually makes a put or delete, HTTP put or delete. And we take that pre-flight request and we match it to the potential would-be request. And if we find a match, then we look what is the metadata for CORS for that particular controller method, and we reply automatically. For global configuration, so it may still be convenient to apply CORS globally. Inside Spring MVC, you can do things like automatically ensure that certain headers are listed as allowed. You don't want to have to list that on every individual controller, right? So it's a kind of a mix of global and fine-grained configuration that you want to be able to do. And they're layered together, so this creates a very nice configuration model.
I have a question. So
Yes?
Does it mean that they're disabled by default? I thought they were.
Yeah, so basically the way it works with pre-flight requests is that the browser is asking, is this allowed for this origin? And then in the response, you're also supposed to list explicitly any headers outside of a certain known headers like content length and content type. Anything else you're supposed to explicitly list because otherwise they wouldn't be allowed on subsequent requests. So you have to kind of explicitly mention them in your CORS config if you're locking down using CORS configuration.
So this annotation that you showed before is not taking care of it. You have to use it.
Yeah, so this annotation doesn't automatically know that you have certain headers that should be allowed.
So when I'm going to make a head call to the controller, it's not going to respond with this header?
Yeah, so this is a little different from HTTP head requests. We're going to talk about that as well. This is more related to CORS and the way that the browser and server exchange information about what's allowed. And this is, like here, for example, you're basically saying that only clients from this origin are allowed. If you got the JavaScript from this origin, then it's allowed to make calls to that domain. And then as far as anything else, we may extract, for example, HTTP methods. If you have explicit request header listed in your controller method, we would extract that information as well automatically. But in the case of XCSRF token, that's a Spring security functionality, which is configured separately. It's not on the level of your controller. So we don't have access to that information automatically. Yep.
The previous one.
Yep.
This is on the server side, right?
Yep.
And you are restricting with that annotation. You're saying that it should come from example.com.
Yep.
But by the time server sees it, it only has to be an IP address.
So the question is about the format in which the origin is expressed in the configuration.
The server sees the client only as an IP address, unless you have like two-way SSL or something.
So this is actually matched to a header called origin header. So when the browser sends a request, it puts in the origin header the request, the domain that it's asking for, and the origin where the JavaScript came from. And that's what we're matching to. And separately, there's a coarse filter, and that's something we added a little bit later on, basically as a result of feedback. It uses the same underlying functionality, but it's packaged as a filter. So it's basically just global-only configuration. And this is very analogous to similar filters from Tomcat and Jetty, except it's bundled with Spring. And it is an alternative to cross-origin annotation. One reason why you might want to use this instead of the nice configuration model otherwise is that you can put this filter in front of Spring Security and deal with CORS ahead of Spring Security. Because otherwise, if you have Spring Security, it means that you have to open up HTTP options to allow pre-flight requests. And of course, HTTP options, pre-flight requests are not authenticated. So it's there's a bit of a risk there in allowing the request to go all the way to Spring MVC. But I think there's a planned feature in Spring Security to actually make that a little bit more tailored for Spring MVC. So when it knows that there's dispatcher servlet, that's when it actually allows it, not otherwise. So those are two alternative options. HTTP options. For whatever reason, for a long time, we haven't supported that, and it's finally time. We're adding this in version 4.3. In fact, it's already in the nightly snapshots. Essentially, what we do here, and what we've always done, is that if there is a request coming in which does not match to any request mapping, we will raise a 405 method not allowed. So we've always had the capability because we know what HTTP methods you are mapped to. But in this case, we're actually going to explicitly support an incoming request for HTTP options, and we're going to provide a meaningful response back with an allow header that indicates what are the allowed HTTP methods. So now this will just work for any request mapping method automatically. Also, we're adding support for HTTP head. Somebody had a question about that, and basically, the way that HTTP head is supposed to work, according to the spec, same as HTTP get without the body. So you see exactly what headers, but no body. Not sure how often this is used in the wild, but it is something that can be, considered a bug that we don't support since it is a spec method. So basically, the way that we support that is if your request mappings allow get, now they implicitly also allow head. We just let that process. Then we ignore the body. We just look at the size of the body that's written, but we don't actually allow it to go through to be written so that the content length can reflect the size of the body, but there's no actual body. There is some things that have happened around HTTP caching, some good updates that you may not have seen. that's worth knowing about. So there is first of all, the modern, there has been an update with HTTP 1.1 around HTTP caching, kind of moving away from some of the older style pragma and no cache headers that used to be there. Now, basically, cache control response header is pretty much the main recommended way of dealing with caching. And there's a lot of different directives that come with the cache control response header. And for that, we have a cache control builder, which supports some of the common scenarios. So for example, you can prepare a cache control response header. The first scenario is where you actually want to enable caching for the response. Any proxy or the browser may cache the response, in this case, for up to 1 hour. There's no need to set a whole bunch of other headers like it was necessary in HTTP 1.0. The second one is where you want to prevent caching, and that's a simple cache control header with no store directive. The third one is where you want caching, but that caching should be conditional so that the browser is sending etag or last modified headers, which are then compared on the server side, and the response is a 304 or a 200 with the actual response if it has changed on the server side. So those are the three main cases that are reflected in the builder. But then you can do pretty much any combination if you have a more advanced scenario. Any of the cache control directives are exposed. So where you might use this is, for example, if you're building a response entity, a response that's based on a response entity. This is another thing worth knowing. I'm not sure if you've seen the response entity builder, but instead of saying new response entity, now there's a nice builder that lets you prepare common type of response entity scenarios. And in this case, you can see that the cache control is supported, and you can indicate max age and any of the scenarios I showed on the last slide. And also, if you include an etag or last modified in the response entity, we'll automatically check against the request. And if the request contains an etag or a last modified stem, if those match, basically we return a 304 instead of the actual response. So simply by adding an etag or last modified, we do those checks because it makes sense to do that. And for 4.3, we're also working on conditional put and post, which is again the same idea. Cache control is also in places that you might be currently configuring caching, like the Web Content Interceptor. That's when you're applying caching to a certain set of URL patterns. And also for static resources, which is also exposed in the MVC Java config and the XML namespace. This might be kind of a interesting one, especially prompting upgrades to 4.3. So basically in 4.2, we added support for custom request mapping annotations. Anybody done that? Like, let's say you do your own at get or at post or at JSON get, at JSON. So you can basically design your own annotation instead of request mapping. And you do it by, you can put request mapping on your own annotation, but you can also design new attributes and you can alias translate how they map to the request mapping. So you basically create your own annotation. And out of that idea, in 4.3, we're adding some built-in annotations. So where request mapping is a very kind of general mapping annotation, it allows you to say, you know, several HTTP methods and, you know, a whole bunch of things, several URL patterns. Here we have actually very specific dedicated get mapping annotation. So that's a kind of shortcut, so you don't have to say at request mapping path method. That allows you to just say get mapping and just the URL and nothing else. So the idea is that these are going to be very focused annotations on the individual use cases, and they should allow kind of better way to express. Also, if you're using consumes and produces with media types, you might be using very long constant names. We're going to try and improve on that to make nice and sweet and short annotations for mapping purposes. Some other additions. In 4.2, we added aliases for any of the Spring annotations. So, for example, instead of saying value equals path, which was kind of the default attribute name in annotations, now you can actually say path equals, and that's more readable. We have new annotations for session and request attributes. So if you simply want access to a request attribute or a session attribute, then you can use those new annotations in 4.3. There's a new attribute on model attribute called binding, and that allows you to prevent binding from happening. So if you just want to load access an attribute from the model, but you don't want data binding applied, you can do that. And there's also a REST controller advice, which is basically the same idea as controller and REST controller, but controller advice and REST controller advice. So that basically means that any exception handler method in that controller advice is going to be assumed to be doing response body by default, not view resolution. On the HTTP client side, so we've had async REST template for a little while now, and that's basically allows you to make a call and then be notified through a listenable feature when the response is done. And also we've added Netty and OKHTTP as client technologies, so you could use Apache async HTTP components client, or now you can use also Netty in OKHTTP. And also for Spring Framework 5, we're working on a non-blocking reactive HTTP client, which is already, there are some early versions of that. It's taking a slightly different approach. Instead of the REST template style many methods, it's more of a fluent API, a bit more like the mock MVC if you're familiar with the Spring MVC testing support. It's a bit more like that style. And a few things to mention in the layer. So this has been around since Spring 4.1, but I like to point it out because I think it's a really neat feature of Spring MVC, which is I don't think it's necessarily very well known. So we've had the ability to serve static resources like images and CSS and JavaScript for some time, and basically the way that came around was, if you remember in the past, we used to map the servlet to by prefix. So you would say /app/star, and then all of your URLs would be prefixed with app. And then at some point, we switched to mapping / because we want clean URLs. But basically, when you map to / in the servlet mappings, that makes it the default servlet, which means that any request that comes in goes into that servlet. So what do you do now with JavaScript and images? That's where we started to add the resource handling so that you can take a URL and map it to an image on disk and then serve that back to the client. Well, in 4.1, we gave that a major upgrade, and we created very flexible resolution between URLs and resources. So if you have a URL and you want to translate that into a resource on disk, also applying transformation. So here's a concrete example of that. If you have CSS or images, one question is how long should that be cached for in the browser? And this is a kind of challenge, right? Because on the one hand, you really don't want, any website, any page has easily 50, 60 resources on that page, and that's very costly, especially for mobile phones making so many calls, individual calls. So you want to cache aggressively, but on the other hand, if something changes, you really don't want to miss out on that change. You want the client to see the latest. So one technique for dealing with that is called cache busting, and that, I think, comes from the Ruby on Rails world. In fact, we had a feature request that started all this. But this is something also known as fingerprinted URLs. And if you're dealing with Git, you might be familiar with this concept. It's basically you're calculating an MD5 hash based on the content of the file. And then the way you know that there's a new version is when you recalculate the content, you see that there's a new MD5 hash, you know something changed. So it's basically entirely content driven. So this is now supported through, when a URL comes in, obviously this URL does not match directly to a CSS file, but we understand that that's a version URL, and we extract the version and then we look at the actual file, we compute the MD5 hash, and if something's changed, we give, we basically prepare a different URL, and that causes the browser to see it as a totally new URL, and the caching is busted. So basically, you can serve these kinds of URLs to the client with aggressive cache headers like 1 year out, and as soon as something changes, boom, the client sees a new URL, gets rendered in the HTML, and everything just works. There are also strategies for versioning where you can prepend the version to the URL, and why. And that prefix can be, for example, a commit SHA from GitHub. If your project is on GitHub, for example, you can compute, you can take the latest commit when you're deploying your application, and that serves as your prefix. So as soon as you have a new version of the application, that causes all of your JavaScript to be refreshed to have different URLs. And the reason why you might do this for JavaScript is because in JavaScript you have module loaders. And module loaders tend to do the same thing. They try to manage the JavaScript loading. So they deal with whether something has been already loaded, etc. So you really don't want to actually confuse module loaders with something like content versioned URLs. This is more applicable for CSS and images and fonts and things like that. The other interesting aspect which we take care, I mentioned that we do flexible resolution and transformation. Well, imagine that you're loading a CSS file. A CSS file itself can have links to fonts and to images internally. And those images also need to be versioned. So basically, we transform, when we have this in place, we transform the CSS as well to have versioned URLs inside of that too. So those are the kinds of things that this enables, these mechanisms. And this was part of an overall design effort to support modern web application development, where to work with static resources is actually a relatively complex thing to do, because you have to deal with optimizations like minifying and concatenating your files. You need to deal with sometimes transformations if you're using things like Sass or less. You could be using CDN to refer to your resources. Also, you want to make sure that when you're developing and debugging, in the debugging environment, you're getting the right version of the file with that is not concatenated and minified, because you want to be able to debug. And the other thing is that nowadays, putting JavaScript and CSS files on the source main web app is increasingly not adequate, right? JavaScript side for standalone for modern web applications is a pretty sophisticated client side. There's tests. There may be you may be using Bower to manage your versions. Suddenly, you find that under source main web app you have hundreds of files, literally, just like you have a Maven repository under your home directory. And in many cases, it makes sense to actually create a separate module for your client-side resources, and then the question then becomes, how do you work conveniently with that in development? And I'll point to some more resources about this, but this was all went into the kind of the design and the thinking when we thought about resource handling and what we designed. So basically, our support that's there is meant to work with different approaches. For example, using JavaScript build plugins like Gulp and Grunt. How many are doing something like that in your applications? Quite a few hands. I mean, it's obviously not the easiest route, but once you jump over that initial hurdle, from there, it's basically a question of what does the JavaScript world do to do X, Y, Z, and then you Google it and you find it, and that's very, very good to be on that same place. If you're more on the side of using Java-based tooling for doing these things, it's a more limited mind share, right? So it's easier, but it's also not as fully featured necessarily. WebJars is another approach where you have the JavaScript kind of packaged as a jar and managed through Maven. So that's something that we support as well explicitly. In fact, it's built in. And also, we didn't build a full asset pipeline. This is a terminology that comes from Ruby on Rails. But it's basically where they manage all of the concatenation at runtime minifying, etc. But there are examples already of frameworks that are built on top of what we provide in Spring MVC. There's one called WUIC, which builds on top of what we provide and gives you this kind of asset pipeline functionality. So it makes it really easy to deal with static resources. And I'll provide some more links on this in a moment. Something else that's worth mentioning, we have script-based templating. So there's a new, this is a long-term standing subject, love-hate relationship with JSPs. At the same time, you have free market velocity. They've been around for a long time. So it almost seems like there's no new modern choices in the templating side of things where other languages have been pioneering and inventing and doing a lot of things. Well, we have TimeLeaf for sure, and TimeLeaf is a great modern web templating choice. In fact, it's the best replacement for JSPs because it's very fully featured in terms of all kinds of tags and supporting all kinds of things that you find in JSPs. But there are some additions here. So for example, if you're in Java 8, there's a Nashorn JavaScript engine, and there's now in Spring MVC a script view resolver which allows you to plug in any JSR 223 scripting language, scripting engine, and the Nashorn scripting engine can be plugged in, which means that you can now configure a script view resolver and then point it to React.js, and now you can start using server-side rendering with React JavaScript that if you are using React in your application, this becomes a very important kind of technique to be able to pre-render your views on the server side. We also have Groovy markup templating, and again, that's another option which is out there. If you already have Groovy on the class path, then basically this gives you a dry markup. So it's basically you're using Groovy DSL to write your view, so you're not spelling out all the HTML tags, and that can be attractive because it's much more, it's a bit like Haml in the Ruby world. That's a similar option on the Java side. And some additional resources, the Spring Reactive project, if you're interested in our Spring Framework 5 efforts, there's already quite a bit of functionality there, but it's still relatively early days. I'm going to be talking again about that tomorrow. There's a couple of links, a previous presentation on resource handling that goes in a lot more depth that you might be interested to explore, especially for structuring, how to structure your code base with client-side code, and how to deal with resources using JavaScript tools. And there's also a resource handling workshop that's a nice addendum to that as well. And that's the end of my slides. Any questions? Yes?
So those examples that you showed, the SHA-1 defines the name of the CSS file, concatenation of CSS and JavaScript file modification. Do we have to use like a new tag library for this, or like HTML post-processing, kind of like?
Yeah. So the question is, when you use the version URLs, how do you plug that into your HTML templates? Do you have to use new tags and so on? It's a good question. If you're using the MVC Java config or the MVC namespace, we automatically plug in a filter which wraps the response. So anytime anybody calls response.encode URL, that gives us an opportunity to actually look at the URL and say, is this a resource URL, and kind of encode it properly, kind of give it the version, embed the version in it. And practically all libraries, if you're using JSPs, you're using the C URL tag, for example. If you're using TimeLeaf, there's also a tag, syntax there, which basically goes through this encoding. So that's pretty much transparent for the most part.
Basically, you have to use the JSTL tags.
Yep. Yep. Any other questions? All right. Thanks for attending. Feel free to stop by or stop me anywhere. And hopefully I'll see you tomorrow.